Okay, kids, we are back and talking about factoring by grouping, but second day we're going to see some more advanced problems. So I just want to kind of recap all the factoring techniques we've learned so far. There are, of course, more. But remember, when you factor, what is the first thing you should always look for is a greatest common factor. That should always be first thing you try to look for. Is there something you can pull out? Then, the other methods we've learned were really all dependent on how many terms you had. That at least gave you a tip off of what to look for. So if you had two terms, remember that's where you would look for difference of two squares, or dots as we called it. And that looked like this. If you had two terms, there's a difference of two perfect squares, and that always factored to this: a plus b, a minus b. If you had three terms, a trinomial, well, that's typically where you looked to unfoil, and that's when it looked like this. Remember, basically like your quadratic, where it was x squared plus bx plus c, and then that factored down to these two sets of parentheses, and because it was x squared, x and x, and then you just had to figure out what two numbers multiplied to c but added up to b. And what we just learned was, well, what if there are four terms? Well, then that's where you look for this grouping method. And those kind of look a little different each time, so I'm not going to try to represent that here with any specific example. And there will actually be one more we learn about in the coming days here. And that will be, what about if it's a trinomial, but it's not just x squared? What if there's a number out in front, like 2x squared, 3x squared, etc.? But we'll learn how to deal with that. But we use grouping to get there, so this is why we learn grouping first. Okay, so just keep in mind, all these are going to maybe be mixed and matched in these problems, so you got to have that mental checklist going. So first things first, number one here. I've got 1, 2, 3, 4 terms, but the first thing I want to look for, is there a GCF I can take out of all four? 1, 2, 3, 4, nothing goes into all three of those. There are no variables that I can take out of all four, so there is no greatest common factor. Now there's four terms, so that's where I'm going to try this grouping technique. Focus on the first two. Is there something you can take out of just those two terms? Yes, I can take out 5 out of 15 and 10, and I can take out y. So 5y. And then when you take out 5y out of these two, you're left with 3x minus 2. And remember, with grouping, you're basically hoping, you're looking to make that same group here. But it should almost just happen naturally. You shouldn't have to go out of your way too hard to make it usually. Now this group here, there's no real GCF that you can take out of these two, except notice that it starts with a negative. So we will take out -1. Or if you just want to write the negative out in front of the parentheses, fine. And that negative kind of helps you accomplish what you want anyway. That will be 3x, and -1 times -2 gives you +2. And what you wanted was to have that common quantity there anyway, so you know you've done it right. So now you can take out that common quantity of 3x minus 2, and your other quantity is made up of these two coefficients, 5y minus 1. What you always got to be on the lookout for, though, remember, is, can it go further? Can either of these go further? They're both two terms. There's no greatest common factors I can take out, and neither of them are difference of two squares, so you're good to go. That's done. Looking at this group right here, is there a greatest common factor I can take out of all four terms? 2, 5, 18, 45, no xx, no x there on the end, so no greatest common factor. It's got four terms, so let's go to grouping. What can you take out of this first group? Nothing out of 2 and 5, but I can take x squared out of those, so x squared is my GCF, and then I will have 2x plus 5. What can you take out of this group? It starts with a negative, so I'm going to look to take negative something out. even at just negative 1. But in this case, 18 and 45, I can take a 9 out. So that will be minus 9 on the outside. And negative 9 times what gives you negative 18, negative 2x. And negative 9 times what gives you negative 45, plus 5. And there's your common quantity. So again, if you like to put the 2x plus 5 first, that's what I always do, just as the way I was taught. And then I put the x squared minus 9 second. But some people always put the common one to the back, and the x squared minus 9s are out in front, and they put the x squared minus 9 out front. No biggie. But look at this. Are we totally done? This cannot go any further. But x squared minus 9, that should be jumping out at you. That's a dots right there. That's a difference of 2 squares. So this 2x plus 5 can't factor any further, but I still write it. It's one of the factors. And x squared minus 9, what squares to give you x squared? X. So x and x. What squares to give you 9, or in other words, the square root? That's 3. 1 plus, 1 minus, doesn't matter which one is which. And there you go. Neither of them can factor any further. You're done. And so that was sort of a double factoring step, so just got to watch out for those. You got to train your eye to always look if you can factor any further, because people aren't going to ask you to do it. They're just going to say solve this problem. And now the last couple here. This is 8x squared there. The copier got a little funny there. And if I look at these two, is there anything I can actually take out of all 4 first? It's anxious to get right into the, I understand it's understandable to jump right into the grouping, but take a moment and look for that GCF. There isn't one, so now we'll go right to the grouping. What can you take out of these two? 3x. When you take 3x out, you'll have 4x squared minus 1. What can you take out of this group? It's a positive in the middle, so be looking to take out a positive, and you can take out 2. And that's it. But that's all we need, because now on the inside will be 4x squared minus 1. And now I can group this 4x squared minus 1. I can take out that common 4x squared minus 1. 3x plus 2 makes up the other quantity. And take a good look. Is it done? This one right here, 4x squared minus 1, that's another difference of 2 squares. That's a dots. So let's break that down into 2 sets of parentheses. The 3x plus 2 can't break down. This breaks down to what is the square root of 4x squared? 2x, and 2x plus minus square root of 1 is 1. There we go. Totally done. None of those can go any further. And lastly, oh, look at this monster right here. Is there anything you can take out of all 4? Yes, actually. I see lots of variables and numbers. I definitely see I can take a 2 out of all of these. So 2. I definitely can take out some x's, in this case x to the 3rd. Remember, look for that smallest exponent, and they all have some x's, but x to the 3rd is the lowest, so that's what I know I can take from everybody. And they all have y to the 1st, so I can take y to the 1st out. Now when I take that out of all of this, what am I left with? X to the 4th plus 9x squared minus 4. Remember, 2 times negative 4 gives you that negative 8. X squared, because I took x to the 3rd out of x to the 5th. I took the y away. Out of negative 72, that's divided by 2, will give you negative 36. I took x cubed and I took y, so actually that's it right there. So I guess I could have ended the parentheses there. But now, can this go further? You've got 4 terms on the inside here. So really, this is now like its own problem. Well, we're going to just treat it. 4 terms, I'm going to use grouping. I'm just doing it on the inside of this, set of parentheses here. So when I do this, just be careful with all your parentheses and your enclosures. I'm going to make like a big set of brackets to represent all this grouping I'm doing is happening on the inside here. So grouping this, what can you take out of these two? X squared. And when I take x squared out of that, I'll have x squared plus 9. What can you take out of this group? Well, I see a negative in the middle, so I want to take out a negative something. And in this case, negative 4 looks to be it. When I take out that negative 4, I'll have positive x squared, and that will be plus 9. Notice there's our x squared plus 9, our common group. So 2x cubed y. And on the inside here, that common factor of x squared plus 9. And that other factor is now made up of x squared minus 4. So now this is factored. We've got 2x cubed times y times x squared plus 9 times x squared minus 4. So now it's factored. It's all being multiplied, no pluses or minuses in between the terms here. But can it go any further? This is done. That's x squared plus 9. That's a sum of two squares, and that does not factor. But x squared minus 4, that's a dots right there. Difference of two squares. So 2x cubed y, and now I don't need these brackets because everything's being multiplied. And x squared minus 4, that's going to factor to x plus 2, x minus 2. And there's all your factors. They could be listed in different orders if you like, but that should be it. It doesn't break down any further. Okay, if you could handle that one, kids, then you are doing pretty well, because there was a lot going on in there. If you have any questions, just email me or come to the Zooms and we'll do a bunch more. So hang in there and keep working on it. See you later, kids.